15a says that if cos 2a equal 3/5, then we want to find cos squared a. So we use this identity. Let me just remind you where that comes from. Here we have all our identities. At the bottom, we have these double angle formulas, and from the double angle formulas, we get a formula for an identity for cos squared and sine squared. So we're using this one right here because that involves the quantities that are given in this example. Here it involves cos 2a right here, and we want to find cos squared a. So all we have to do is substitute a 3/5 for cos 2a. So we have 1 plus 3/5 over 2. And I'm going to simplify that. I'll multiply top and bottom by 5 to get rid of that denominator. Okay, so we have in the numerator, 5 times 1 is 5. And 3/5 times 5 over 1, that's 3. 5 plus 3 over 2 times 5 over 10. 8/10, which is equal to 4 over 5. In B, we want to find the exact value of cos 2 theta given sine theta is equal to 3/5. All right, so let's look at see what identity we're going to use. Let's look at our identities here. And here we have identities for cos 2a or cos 2 theta. And we are given, let's remember what we're given. We're given sine. Okay, so we might as well use this one because we're given sine and we want to find cos 2 theta, so we'll use that. Okay, so let me write that down. Cos 2 theta is equal to 1 minus 2 sine squared theta. We don't even need the fact that theta is between 0 and 90 because we're going to square the value for sine theta. Okay, so it really doesn't matter. Even if this were a negative value, once we square it, the negative sign would become positive. So let's look at that. 1 minus 2, 3 over 5 squared. So we have 1 minus 2 over 1 times 9 over 25. Let's change that 1 to 25 over 25. So we can combine our fractions, minus 18 over 25. And so we have, 25. So we have 7 over 25. In 15c, it says if cos 2a is equal to negative 2/3. Let me just pull that down. Okay. Cos 2a is equal to negative 2/3, then what is sine squared a equal to? So let's look at the identity. We're going to use this one. Sine squared is equal to 1 minus cos 2a over 2. Let's write that down. And we're going to put cos 2a is equal to negative 2/3. So we have 1 subtract negative 2/3. We have this double negative going on here over 2. So that's 1 plus 2/3 over 2. And I'm going to multiply top and bottom by 3. 3 over 1. In the numerator we have 3 plus 2. And 6 in the denominator, or 5 over 6. So that's sine squared. That's what we were asked for. In 15, we want to find cos A plus B. So first let's use our sum formula for cosine. Cos A plus B, cos A, cos B, minus sine A, sine B. Okay, and we're told that A is in quadrant 1, and B is in quadrant 3. All right, now let's fill in the values that were given. We have sine A is 2/3, so we'll put it here. And we have cos B is minus 4/5, so let's put that here. So let's start by finding, let's find cosine A. Okay, so we're going to draw a little triangle. And we'll put A in our triangle because A is in quadrant 1, so we can put that in our triangle. Okay, we have that sine A is equal to 2/3. That's opposite hypotenuse, opposite over hypotenuse. So this third side by the Pythagorean theorem is the square root of 9 minus 4, or square root 5. And remember, we're in quadrant 1 where all the trig values are positive, so cosine is square root 5 over 3. And now we want to look at B. We want sine B. So we'll draw another little triangle for B. Let me do it over here. And I'm going to put reference B, because B is in quadrant 3, so I put reference B over there, RB. Information about B, cosine minus 4 over 5, adjacent hypotenuse. Let's do for reference B, adjacent hypotenuse. And this is a 3, 4, 5 right triangle. So now we want to know sine. Well, sine here is 3 over 5, and we're in quadrant 3, so that would be minus 3 over 5. So we filled in all our values. I'm not going to continue this, but we can just multiply and subtract and get cosine A plus B that way. In 17, we have an identity that we want to establish. So the first thing I did was convert this secant theta to a cosine. So now everything is in terms of sine and cosine. And now I have these two terms, and I'm going to combine them by getting a common denominator of cosine theta times 1 minus sine theta. So I'm going to multiply top and bottom of the first fraction by 1 minus sine theta. And I'll multiply out that numerator, so we have 1 times 1 for the first. For the middle, we have minus sine theta plus minus sine theta, that's minus 2 sine theta. And last times last, that would be plus sine squared theta. Let's look at the second fraction. We're going to multiply top and bottom here by cos theta to get that common denominator. So here we have plus cos squared theta. Now I see sine squared plus cos squared. That I know is equal to 1. And I'm going to add the 1 and the 1. And so in the numerator I have 2 minus 2 sine theta. And here we have cos theta. Just copy that denominator. 1 minus sine theta. Now looking over to the right, we would like to obtain 2 over cosine theta. Well, so it would be nice, here we have a cosine theta, if we could do some canceling. Well, if we factor out a 2 from this numerator, you see that we could cancel 1 minus sine theta from the numerator and denominator, and we are left with 2 over cos theta, like on the right-hand side. And then that establishes the identity. We have another identity that we want to establish in number 18. So let's see, I'll put my dotted line here for the left and the right sides. Here we have 2 secant squared theta. I'm going to change that to 2 over cos squared theta. Since the left side is in terms of sine, I change everything over to sine and cosine. Let's add these 2 fractions together. The common denominator is 1 minus sine theta times 1 plus sine theta. First fraction, we multiply top and bottom by 1 plus sine theta. So here I'll get a 1 plus sine theta. And here we multiply top and bottom by 1 minus sine theta. So I'll get here a 1 minus sine theta. So we're going to have these 2 cancel, and we get the 2 on top like we have over here. In the denominator, when we multiply out, we have 1 minus sine squared theta. And that's equal to cos squared theta. So now we have the right-hand side. In number 19, we have a value for sine A. And we're told that A is in quadrant 3. So let me just put quadrant 3 under here. And we have a value for cosine B. And we have that B is in quadrant 4. So let me put that here. First, we want to find cos A minus B. So I think it pays just to get all the information, or draw 2 triangles, one for reference A and one for reference B. All right, so first we're looking at angle A. So we're going to draw a triangle and put reference A in here. And next to A, let's write quadrant 3. We have sine A is minus 2 over 3. That's opposite over hypotenuse. So that would be, for reference A, that would be 2, 3. And this side is the square root of 3 squared minus 2 squared, square root of 9 minus 4. So that's our triangle for A. Let's look at our triangle for B. And let's write down that B is in quadrant 4 just to keep everything in one spot. Let's put a little triangle. Put B here. Actually, again, it's really reference B. So let me put an R over there, reference B. And we have that, let's see, cosine B is 5 over 6. That's adjacent hypotenuse. So this third side is 36 minus 25 in this, under the square root. Or the square root of 11. And now we can figure out these identities. Let's write out cos A minus B. Let's just write it out. Cos A, cos B, plus sine A, sine B. So for cos A, we were given that. We have 5 over 6. I'm sorry, that wasn't cos A, that was cos B. Let me correct that just a minute. Okay, I'll put the values that we have in parentheses. So let's see, we have sine A. Let's put that here, minus 2 over 3. And we have cos B. Let's put that here, 5, 6. Now we need cos A, so that would be square root 5 over 3. Quadrant 3 would make it negative. And then we have sine B. That would be square root 11 over 6, and we're in quadrant 4, so that would make it negative. And I'm just going to leave it as like this. Okay, you can get a common denominator of, or combine, both denominators are 18. You can write a combined form, but I'm just going to leave it like this. Next, we want to find sine A plus B, so I wrote out that sum formula, and let's just fill in what we have. So let's see, we have sine A is minus 2/3, so I'll put that here. And we have cos B is 5/6, so I'll put that here. And now we want cos A and sine B. Cos A, let's go here. So we'd have square root 5/3, and we're in quadrant 3, so that would be negative. And sine B, let's go over here. That's opposite over adjacent, and we're in quadrant 4, so that would be negative. Okay. Now we're going to look at sine 2A. So we have this double angle formula. Sine 2A is 2 sine A cos A. So let me write that. Okay, so let's fill in. We have, let's see, sine A is minus 2/3. So we just need cos A. Let me just find those triangles again. There we are. And we have cos A. Adjacent over hypotenuse, and quadrant 3 is negative. And don't forget that 2 in front. And for the last one, we're looking at cos A over 2. So let's look at our trig identities. All right. And we're going to be using this identity right here. Here we have an angle that's half of this angle. So, oops, sorry about that. So let's use this one. I'm going to copy this over. Here I'm going to write A over 2, and here I'm going to write A. So as long as what's written here is half of what's written here, we will be writing a proper identity. Okay, so let me write that out. Okay, so I have cos squared A over 2 is equal to 1 plus cos A over 2. Again, instead of writing A here and 2A here, I put A over 2 half and double that here. Okay, as long as you have angle and double the angle, the identity is true. So we want to find cosine A over 2. So all we have to do is put cosine A in here. Now cosine A adjacent over hypotenuse, and it's going to be negative because we're talking about quadrant 3. So I'm going to put minus square root of 5/3 in. So we have 1 minus square root 5/3 divided by 2. Let's simplify. Let's multiply top and bottom by 3. So we have in the numerator there 3 minus square root 5 over 6. Now this is cos squared, right? That's cos squared, and we want cosine. So cosine A over 2, it's going to be either plus or minus the square root of, I left some space here. We'll decide if it's plus or minus, depending on what quadrant A over 2 is in. So what are we told? We're told that A is between this and this. Let me write that down in terms of degrees. So A is between 180 and 270. So A over 2 would be between 90. This is 90. Let me just write 90. And 270 over 2 is that's 135. 90 and 135, that's quadrant 2. Okay, so A over 2 is quadrant 2, where cosine is negative. So I'm just going to put a negative sign right there.